Hi everyone, today we're talking about rigid transformations. As a reminder, you do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you already got it. But be careful, make sure you don't fast forward too much that you miss out on something important. Alright, so rigid transformations. Rigid transformations is just a vocabulary word, and it's referring to transformations that don't change a figure's size. So the figure just changes in location alone or location and orientation. So the shape itself and its size don't change. So it's kind of like when you create an image, it's like you're just cloning it, but it's just somewhere else or it's just faced in a different direction. So think about rigid transformations as clones. They're called rigid transformations because you're just like shifting it to another location and twirling it around or something. It's a rigid change. You're not pulling it out and making it bigger or minimizing it to making it smaller. Um, Rigid transformations, we've already learned 3 of them. So there's 4 transformations in total: translation, rotation, reflection, and dilation. But only 3 of those are called rigid transformations. Those are translation, rotation, and reflection. The reason why dilation is not included on that list is because dilation actually changes a figure's size. So only the 3, translation, rotation, and reflection, together are referred to as rigid transformations. And it's important to note that since they don't change a figure's size or shape, the properties that stay the same are angles and side lengths because your figure hasn't changed its size. So all the angles in the clone, the image, after you've transformed it, should be the same. And since you haven't changed the figure size, the clone or image, after you've changed it, should have the same side lengths. So they should also have the same perimeter, that means all the sides added together, and they should have the same area, that's the length times the width. We're going to go over some problems later on, but be sure to jot these down in your notebook first. Okay, so remember, you're just creating a clone with the rigid transformations. You're not changing the size. So angles and side lengths should remain the same. Okay, so here is an example of a type of problem that you could be asked. In this problem, they're telling you that triangle ABC is translated 6 units to the left and 1 unit up to create triangle A prime, B prime, C prime. Go ahead and pause the video and try it on your own first. They want to know what's the area of triangle ABC. All right, we see that triangle ABC, the original, is translated, so that's a rigid transformation, meaning it's just creating a clone. The new image is going to be exactly like the old image. It's just going to be located in a different location. So the angles and side lengths are the same. We want to know the area of triangle ABC. In order to get that calculation, the area, remember area of a triangle is length times width. And since it's a triangle, we have to divide it by 2 because the area of a square is length times width. A triangle is half of that, so we have to take length times width and divide it by 2. Okay, so we do need more numbers here. Where can I get those numbers? I can get it from its clone, okay? A prime B prime is 6.1, so then that means the original AB would also be 6.1 because it's a clone. But be sure that you match it up. Angle A prime is 18 degrees, so this angle has to be 18 degrees as well, angle A. It can't be 18 degrees for C because those don't match up. One's A's angle and the other one's C's angle. So you want to make sure that it is matching up. Okay, and that's all we can get from the other one. Now we can figure out our area. area is length, 6.1, times width, 2. And remember, divide by 2. Multiplying by 2 and dividing by 2 is the same, so those two actually cancel each other out because they're inverse operations. I can take 6.1 and double it, but then I'm going to half it again, so I get right back to 6.1. So the answer is actually 6.1. It's 6.1 units squared. So all rigid transformations is telling you is that, when you perform translation, rotation, reflection, you create a clone. So you can take measurements from the other image because they're the same exact thing. Okay, the next type of problem that you could be working on is preserved properties. So in these types of problems, they're telling you the rigid transformation that's occurring, and then you have to choose the correct statements about the unchanged properties. They're a little bit more difficult, so we're going to do this one together. For this problem, they're saying that triangle A prime, B prime, C prime is the result of reflecting triangle ABC across the line L. We know reflection is a rigid transformation, so that means we have the same angles in our clone, and we also have the same sides in our clone. Okay, it's a reflection. Let me just go ahead and, kind of sketch this, what this would possibly look like. Let's see. It's gonna be, the A is gonna be kind of similar in the amount of spots away. And remember, I'm just making a sketch of this. The B would be just on this side, but the same amount of spots away. So it's going to be like over here, I guess. Just kind of making a sketch. And then the C. Okay. Kind of something like that. So I just counted how many spots away for the A, how many-ish spots away for the B, same for the C, and it ends up looking like that. It's a little wider than my original one, but you kind of get my point. All right. They want to know is side BC, this one right here, and side B prime, C prime, are they both perpendicular to the y-axis? Here's the y-axis right here. Perpendicular means that you're going in opposite directions. One's going up and down, the other one's going left to right. That's the opposite of parallel. Parallel would be like if they're going in the same direction. So they want to know, is BC and B prime C prime, are they both perpendicular, going in the opposite direction as the y-axis? That looks like a no, because B prime C prime seems to be going in the same direction, and BC seems to be going in the opposite direction. So they're not both perpendicular to the y-axis. So I wouldn't choose that one. And then they want to know, is angle B and angle B prime, do they have the same measures? Again, this is a sketch, so they look like they don't have the same measures, but we know that since a rigid transformation of reflection was done here, they should produce the same angles. So that one should be selected because it's a rigid transformation. The angles should be maintained the same, even though my picture is disgusting. And the perimeters of both those images, are they the same? Well, they should have the same side lengths because they're a rigid transformation. So that should be the same. Yes, they should have the same side length, so then the side length should add up to the same amount. Okay? So again, you might have to make a quick sketch. This one was a little difficult because it's like a sideways reflection, but, and then with the whole perpendicular thing. So I actually had to sketch that one out a couple of times because it just looked weird the first couple of times. But you're just using the fact that a rigid transformation has maintained the same angles and same side lengths. Let's do one last one. For this problem, go ahead and pause the video and see if you can try it on your own first. This is a rotation by 90 degrees, and we want to see which ones are it. Okay, so result of rotating AB about point P. Okay, so they're rotating it around here. This is the point of rotation. This is like the elbow right here. 90 degrees. Okay, they don't really tell us in what direction, so we can always assume it was, 90 degrees this way. So it looks like the original one was here. It got rotated 90 degrees. Let's just say it got rotated this way. So then B prime would be here and A prime over here. Okay, rotation is a rigid transformation. So we know angles and side lengths are going to be the same. Again, we just sketched this out. Let's see what it's asking us. AB, that side length, are both perpendicular to the x-axis. So this is AB and this is A prime, B prime. Are they perpendicular? Are they going in the opposite direction as the x-axis? Opposite direction would be going up and down. Neither one of these are going up and down, so that's a no. And then A and A prime have the same coordinates. Like, are they located at the same place? Is this A located at the same coordinates as this A prime? No, they're completely different. Rotation changes location. AB and A prime, B prime have the same lengths. That one, yes, because they have the same side lengths. But they're not going to have the same location at the end because we moved the location. And then the perpendicular stuff, like probably not because your orientation has changed. So one was going left to right, the other one's going kind of like diagonally. It's not perpendicular, the opposite direction as the x-axis. Neither one of them is going straight up and down. So it seems like C is the only answer there. And that's correct, okay? So they're really trying to test and see if you understand what changes and what doesn't change. The only thing that doesn't change is the angles and the side lengths. The other stuff you might want to sketch out just in case they do change. But most of the time they don't change, but I can't guarantee that. Because if this went like a whole, I don't know, like 180 degrees, it might have changed the orientation so that they were perpendicular. So you just got to be careful about that. Okay, let me know if you have any questions as you work on these problems, and I'll see you in class.